Hi everybody. I wanted to let you know how you could do some analysis of the data produced by your sorting algorithm. In this example here, I'm going to be taking a look at selection sort, and you can see I've already collected this data. Here's the number of samples that I'm working with and the time that it took to sort, and as I increase the number of samples, obviously the time increases as well. So I'm just going to grab that information and copy that and put that into a Google Sheet so I can graph it and see what it looks like. So I'll copy that. Here's my Google Sheet. I'll paste it in there. And notice it puts it all in one column there. Now I need to split it up into two, so I'll go to Data and go down here to Split Text to Columns. And Detect Automatically is fine. Sure, it's actually a space between those, but there we go. So if I graph those two things, I'm going to take you through this process here. If I graph those two things, I'm going to put a chart in there. There it is. And I'm always going to be using an XY chart, none of these columns for us. An XY scatter plot, it's called. And you can see that it's curving up, it's concave up, and it's curving up over time there. And I suppose if I've got some tools on here that I could use, I could select that data and then say, you know what, let me analyze this a little bit. Let me take a look at a trend line. But my trend line, I don't think it's linear. I think it maybe is a power equation, some sort of power series, or a polynomial maybe, a quadratic. That would make sense. A second degree polynomial there. Looks like it fits pretty well, and I can, for my label, then I can say, you know what, let's use the equation, and then I'll find out what the equation is for that. And that's nice if I've got one of the regular functions that they give me possibility for here. There's some others here, exponential and logarithmic and stuff that might be useful to me. There's another thing that you can do, however. This is good. You can graph it like this, and if you've got a quadratic function for your sorting algorithm, you might want to go with that. But you don't. You're going to be doing something else. But nevertheless, I'm going to use the same principle here. If we take this data, we can put this data in here and think about it a different way. If I'm trying to understand what the nature of the relationship is between these values here, what I'm going to do is I'm going to grab my time values and move them over here. And here, instead of n, and remember n is the sample size here, and then this is the time. Sorry, here's the time. Instead of looking at n, I could look at n squared. If I think that the time is proportional to n squared, then one of the things I could do is, rather than graphing time as a function of n, I could graph time as a function of n squared. And so the way you do that in a spreadsheet is you just say, I'm going to replace this cell here. This is going to be equal to this value times itself. So I've just plugged in a little formula here. You can see the formula. If you're not familiar with spreadsheets, this is something you can do. I'm plugging in that formula, and I'm going to drag this down to copy that formula automatically all the way down. So you can see that this column now represents n squared. Why am I doing that? Because I think it's an n squared value. And this graph certainly leads me to believe that if instead of graphing n and t, I graph n squared and t, take a look and see what happens here. I'm going to insert another chart. And this is called what am I doing here? XY? Is that working? No. Yeah, there we go. Good. This is called linearizing the graph. And you can see that as I look at those data points now, I'm starting to see a linear relationship. So these two graphs are representing the same relationship. I'm trying to get that over there. Come on. There we go. These two graphs are representing the same relationship. It's just in this case, we are changing what we're graphing so that we can see this straight line here. And that doesn't mean that it's a straight line relationship. What that means is the original relationship was a squared value. And yes, I know that from having done this regression here. Well, here's the challenge. We don't always have these regressions that are available for us to figure out what's going on. So for instance, let's get rid of all this stuff here. If you are working on merge sort is a completely different algorithm. Merge sort is not a quadratic algorithm. Merge sort is supposed to be an n log n algorithm, as are some of the other algorithms you're going to be working with. So let's take a look at this merge sort here, and I've got the same collections of data here. I've got time data as n increases, and I want to graph that and take a look at that. So I'll paste that in here. Data, split text to columns, space. And if I graph this information, I might be able to see some sort of relationship in there. I'm going to insert another chart there, and it looks vaguely linear, and maybe that's true. But I don't think it's supposed to be a linear algorithm. I think it's supposed to be I'm going to get rid of that. I think it's supposed to be an n log n algorithm. So let's see how you take a look at that. Again, I'm going to insert a row here. If this is n, and this is the time, I'm going to move this time over here. And this is what you'll probably have to do for your algorithm, so pay attention here. So this is going to be, I think this is supposed to be n log n. I think the time is supposed to increase as the n times log n of the value increases. Well, that will be true if I graph n log n versus time and I get a straight line. That will be evidence that that relationship is there. So how do I calculate n log n? Well, that's equals, I'm going to have the spreadsheet calculate it. It's going to be equal to n, which is that cell, times the log of, and now I have to put the value and the base. So there's the value, again, comma 2. There's the base. That's the formula I'm going to put for that, and that will calculate n log n. It's a different value. And I'll copy that down so that I'm going to get a bunch of n log n's. And again, I'm not looking for a direct relationship between those two. I'm looking to understand, I'm trying to understand if time increases proportionally to n log n. And that will be the case if I get a straight line from graphing that. So let's insert a chart for those. And it's an XY scatter chart. They've chosen that for us, and it does look very, very linear to me. I could put a trend line in there. Oh, gotta select that. Nice. Put a trend line in, and maybe it's linear, and I'd like to see the, I'd like to see what the function is. So I'll just go ahead and use equation for that. And there I can see what's going on. So it looks like I've got a linear relationship between n log n and time. Here's time up here, here's n log n. And that suggests, again, that we've got an n log n function. There's a little variation there, a little up and down, but pretty good linear form there. Well, last thing that you'll probably want to do then is get some good labels on here. Replace these labels. Time versus n log n for merge sort algorithm. Put something like that in there. Make sure you have units for everything. Here's the time. You should probably have time in seconds. And down here will be n log n equal to sample size. And that's a pretty good looking little graph right there, I'd say. How do you include that in your project? You can download it as a PNG or save it. You can copy it and put it into another document if you like. But that should be a good little graph that you can include then in the work that you're doing. Hope that helps.